industry and from the research and development centers, and we get them in the hands of our material developers. So as they're working on new requirements, they can include the latest and greatest innovations and capabilities into those. So the other half of my job has to do with accelerated capabilities. So we first look at the far left of the continuum, what's coming out in science and technology. And then as we look towards the middle of that continuum, right around the technology readiness level 4 or 5, what we do is we look at focused assessments and different types of experiments. And that might be the Army's Expeditionary Warfighting Experiment that's being conducted down at Fort Benning, or the Army Warfighter Assessment, which is conducted out at Fort Bliss. And we try to get capabilities that are a little bit more mature into those venues so soldiers can get their hands on them, so we can see how they work, see how our capabilities fit that, and make changes to our ideas of how the concepts of how we're going to employ those, or maybe make changes to the tactics and techniques and procedures that we use. So during this presentation, what I'm going to do is try to share some information with you, and this is part of ARCIC's concerted effort to be more open and sharing with industry. What we really want to do is develop a collaborative environment where industry and us, the Army, can work together to solve some of these problems. So, like any good Army officer, I have to use a sports metaphor during my presentation. So if anybody has been around the Army knows we tend to use sports metaphors primarily because it's something people can relate to. So I can really easily draw an analogy between preparation for a football game and what we do at ARCIC. So if you think about a football team, before they go into a big game, what do? They start studying their opponents. They start watching films of how their opponents have played. They watch films of how their own team has performed. They start keeping statistics on key players, on when they use certain plays, how they use them, what is the environment that they're in that makes them do that. Well, we do the same thing at ARCIC, only with when it comes to future warfighting. So what we do is we study and analyze our threats, enemies, and adversaries, and how they behave. We understand what precipitates their actions, and we make grounded assumptions on how they're going to behave in the future. And that's key. It's grounded assumptions. This isn't, we believe that they're going to do some crazy Ivan way off in the future. These are grounded assumptions based upon past behavior that they have. We study the demographic and political trends in the areas where we think there's U.S. interest and likely for U.S. or where that environment, future operating environment might be. And then the part that I think is most interesting to you is we start to identify gaps. And the way we do that is just as I explained. We start taking our concepts, informed concepts about how we're going to operate in a future operating environment. And then we apply our current and future force capabilities into that environment. And we start looking for gaps. What are the gaps that we have across the full DOTML P domains? And so that's where we can work together and help each other. Because when we're analyzing those gaps will in turn become some sort of a solution. Maybe it's a doctrinal solution, maybe it's a training solution, but it also could be a material solution. And industry can definitely help us mitigate that. So to kind of get clarity on all of this, we use what's called the Army Warfighting Challenges. And the Army Warfighting Challenges are 20 first-order problems that we see present themselves against the Army. And you may have heard General McMaster or other TRADOC personnel talking about these Army Warfighter Challenge. And I'll talk a little bit more about them later. But these guide our efforts towards the future force. We use the capability gaps that we derive from applying forces in the future operating environment using our concepts. And we have associated learning demands to the Army Warfighting Challenges and those gaps. And then in the S&T realm, we have what's called the Science and Technology TRADOC Imperatives. And so I'm going to go through each of those imperatives with you briefly, just to talk to you about what those imperatives are, and that's how we try to guide our science and technology efforts. So the first of these imperatives is that the Army must grow adaptive Army leaders that optimize human potential and performance. The Army has got to optimize the performance of each soldier and civilian and team to meet the future challenges, which requires integration, maturing developments, exploration of emerging human performance science, and accelerated development and improve cognitive and physical performance. So what am I talking about there? Things that make the soldier perform better, things that make a team perform better, things that make our civilians perform better. And if you kind of let your imagination run wild here, that could be anything from an IT solution to a medical solution to some sort of human mechanical interaction. And these are critical. Human performance science and the research of naturalistic decision making can be leveraged. To what we want to do there is give our junior leaders the experience of senior leaders. Wouldn't that be great? If we could take a second lieutenant and put him out in the field, but he has experiential decision making of a General Petraeus. I mean, that would be outstanding. So that's what we are working towards, is to give them far more experience and judgment than what their rank would normally have. And then have them build and lead cohesive and resilient and effective teams. So that is key. So some of the areas that we're looking for is our Army leadership for 2025. We want to see develop skills in mentoring, climate setting, and strategic thinking. So if I was sitting where you are, I'd say, okay, that's great, but what does that have to do with me? I'm looking at building something. Well, although these are soft type skills, there's a lot of different avenues out there. There's software, there's human machine interface. There's a lot of different things that relate to this other than just the soft leadership type skills. We also need to create a future holistic training environment, which is live and synthetic, that exploits immersive and full spectrum training tools that enable soldiers to train anytime, anywhere, using embedded capabilities on real equipment. And what that does is that allows us to maintain a training overmatch in a physically constrained environment. And so examples of this that I've seen is where a soldier is sitting on a top of a turret with a weapon system at a range, but instead of firing live rounds down range, there's a synthetic image of that range in front of him, and he's able to engage targets on a virtually, but he's working on the same equipment that he'll go to war with. So looking at that, we also have to improve our cognitive vigilance and physical performance. We have to explore approaches in personal medicine with biomarkers and machine cognition to help us compress decision cycles for the human operators. So if you think about the challenges that we have in a tactical operations centers today, right? It's information overload. Too much information is coming into us. So how do we synthesize that information and compress those decision cycles so commanders on the ground can make quick and accurate decisions? We also have to have research in sleep and nutritional supplements that enable soldiers to improve their performance in extended operations. There's some psychometric tools out there that are physiological sensors and neuroimaging and sensors that show promise and to optimize human potential. So the next slide, and the next area is this maximizing demand reduction. And this is really critical in improving reliability. Because as we know right now, the demand for Army forces is going to increase in the future. But guess what? The force structure is going down, as is budget. There's going to be budgetary restrictions. But the Army has to retain its combat power and maximize its combat potential in its formations. So how do we do that? So we're looking for technologies that increase the reliability, the maintainability, and the resiliency of vehicles and other systems to reduce demand upon the system. We also have to reduce our logistical footprint and reduce our manpower requirements in the area. And so we're looking at robotic technologies which can be easily deployable, and modular systems designed to augment the force and reduce demands. Technologies that eliminate or reduce manpower requirements while sustaining capability become critical. The survey modernization effort is a great example of this. There's an effort that combines affordable systems that autonomously provide position, location, and orientation for artillery assets in a GPS-denied environment. This system could be used to eliminate a military occupational specialty, thereby reducing formations by several hundred soldiers and nearly 100 vehicles. We have robotics and autonomous vehicles, then unmanned and unmanned teaming. That is another area that can leverage success achieved with autonomous aerial platforms, but offer similar opportunities for ground-based systems across the warfighting functions. We're looking at robotic and autonomous systems that can augment, not replace, human capabilities and enhance the force structure to mitigate risk to soldiers. All of this has to work on power, and so another area that we're looking at is operational energies. So we're looking into areas that technologies that increase energy efficiency on our platforms and devices. Equipment that will extend operational endurance and aid in reducing energy logistics requirements. Intelligent management systems that will help leaders monitor the energy usage, eliminate waste, distribute the power effectively, and ensure critical systems have access to power in a time of limited availability. So these alternative power sources, energy harvesting technologies, all will help reduce that demand. And so what that will do is eliminate the need for soldiers on the road in tankers and putting soldiers and our equipment at risk. But when we get down to it, the Army is about warfighting. And so the Army must maintain overmatch. And therefore the next imperative for the Army is maintaining overmatch. We have to have innovative approaches that retain or improve core operational advantages of armored forces. Position, navigation, and timing, P&T, is an area that we're looking at, because we have to have these affordable solutions and technologies that ensure access to position, navigation, and timing in a GPS-degraded or otherwise denied environment. So we have to be able to work even when our GPS system doesn't work, even when the internet or our signal has been interrupted. We have to have mobile protected precision firepower, which is technologies that augment the ballistic protection of combat vehicles against emerging threats, providing both soft and hard kill capability. You know, if you listen to General McMaster, he talks about a future operating concept where future vertical lift brings soldiers into an offset area other than the objective, because the objective has anti-access area denial. And then they need a protected type vehicle that moves them, mobile protected firepower and ground transport that moves those soldiers from that offset to the target objective. So that's really what we're looking at here. But we have to do that without increasing vehicle weight, and we have to scale, the precision fire has to be scalable. Also, critical technologies that will facilitate the integration of unmanned ground combat systems in the manned formations. And all you have to do is walk around AUSA for a little while and you'll see the manned-unmanned teaming and unmanned aerial vehicles demonstrations that are around. And so those are areas that we are looking at. We have to extend our range of fires as well. We have to have affordable technologies such as low-cost extended range missiles that deliver increased precision and effects in all operational environments. And that leads to lethality and effects. We have to have munitions and platforms and sensors that do targeting and mission command systems that provide the commander overmatch to the enemy while employing lethal and non-lethal force with precision and discrimination. So we can't just go out and carpet bomb an area. We have to be discriminate in our targets, and we have to be precise. But all of this doesn't work if we don't have mission assurance. And what mission assurance is really our network protection. We have to ensure that our systems are secure and in order to complete the mission. We have to have technologies that contribute to a cloud-based intelligent enterprise architecture that enable us to operate more effectively and to protect the information environment by preventing our adversaries from degrading and disrupting or interdicting our data. So that kind of leads to the next imperative. How are we going to conduct war? And we conduct warfare by expeditionary maneuver. If you think about the world that we live in today, unprecedented levels of connectedness increase the speed at which events unfold and the range of their effects. Something happens in a small country that most people haven't heard of, and that can have significant effects in the United States, and it can have ramifications all across the world. So these rapidly developing situations, and combined with the enemy's ability to provide anti-access and aerial denial strategies, require our increasingly CONUS-based Army, and if you listen to the panel this morning, they spoke about that CONUS-based Army, to be capable of a rapid global response. We need to be able to go anywhere in the world quickly. Our forces must be able to deploy to multiple austere points of entry so we can pose to the enemy multiple dilemmas simultaneously. So the Army of the future must possess strategic mobility, enhanced survivability, discriminate lethality, combined arms capacity, and logistical supportability. To do this, we need operational reach and agility, advanced rotorcraft, strategic mobility technology initiatives to modernize our current fleet, and something to deploy the force more rapidly. We have to increase our operational reach and agility, and the technologies have to improve range, improve speed, improve payload, and performance in all conditions while increasing the survivability of the aircraft and enable the employment of optionally manned aircraft and manned systems. So these technologies that enable simultaneous force projection, entry, protection, and sustainment in an austere or denied environment enable us to close the seam between forcible entry and follow-on forces, ensuring sustained momentum to seize, retain, and exploit the initiative. We spoke about demand reduction, and that demand reduction will help at the pointy end of the spear. We need to reduce it, and technologies that will help us do that are water from air, water reuse, water distribution technologies that will reduce the sustainment and transportation structures required today. We have to have improved reliability, fuel efficiency, and reduced ammunition and bulk. Vehicle weight reductions are other areas that we have to concentrate on. And we do that through lightweight materials. We need technologies that produce materials with improved specific strength, toughness, and ballistic resistance to weight ratios to contribute to a more expeditionary army. So what did I really say? We need to reduce the weight of our vehicles with ballistic protections that can overmatch the enemy's capabilities. And it has to be tough enough and reliable enough that we can put soldiers in harm's way counting on that ballistic protection. We also have to reduce the weight of vehicle components. And so over the next decade, we're looking at ground vehicle components to achieve a significant weight reduction and in some case volume reductions. These component weight reductions equate to moderate percentage of weight savings for the base vehicle before adding armor. But as I spoke about, we have to reduce the weight of the armor, and therefore protective materials that are able to reduce the weight of armored volumes and account for advances in enemy ballistic capabilities are critical. These weight reductions will improve system performance, mobility, and reduce deployment and employment and sustainment footprints. And that's key, because if you think about it, if we reduce the weight of the vehicle, it can be more agile. And maybe it's just we reduce the weight so we can increase the lethality of the vehicle. But we have to improve our armor and reduce the weight of our armor. And all of that will reduce the total vehicle weight. And so maximizing the weight reduction of a vehicle of a system will require prioritization across component and some subsystem design. We have to use advanced material manufacturing and design optimization, balancing trade-off in weight, performance, and affordability. Advances realized in armor will also favorably impact performance, deployment, employment, and sustainment footprints in a vast majority of the ground fleet. So I talked about how we're improving the vehicles, and I talked about a little bit about the network, but the next imperative is to continuously upgrade and protect and simplify the network. So we need a resilient, simplified, and protected network specifically resistant to cyber attacks that is critical to providing soldiers and leaders with relevant information at the pointy end of the spear. This network is integrated as a common operating environment across the Army. We have to have an intelligence enterprise architecture, critical enabling technologies for distributed processing, exploitation, and dissemination and analysis of information. So when we think about that and we see as you're developing your systems, the first question to ask you is your network system compatible with what the Army is doing? So if the answer is no, that's a time to relook that and get back in touch with the Army network personnel to find out what you can do to make that compatible. So if it doesn't fit into the Army's architecture, then it probably isn't going to fit in. And that's a critical piece of this. We're looking at the intelligent cloud community to enable expeditionary, intelligent, and mission command by 2025. And that'll provide a single global security architecture and common operational picture for cyberspace that's essential to overcoming cyber threats. All of this leads to mission command on the move. We have to enable our commanders the ability to retain being mobile without giving up mission command. And it'll have to increase their agility, speed, discrimination, and effectiveness at all levels of their units. So cyber is going to, and this network is going to be a huge piece of everything we're doing in the future. But finally, we have to take care of soldiers. And if we're not taking care of our soldiers, then we're not doing the right things. And we have to be prepared to treat our soldiers both on and off the battlefield. So medical science is our final imperative. Some of the areas are enhanced prosthetics, improved casualty evacuation, treatment at the point of injury, and prevention and treatment of traumatic brain injury. Continued investment in medical sciences allow improved soldier resiliency, quicker physical and mental healing, smoother integration back into society, and improved quality of life for the soldier. Enhanced combat casualty care. There's a suite of advanced medical technologies that improves survival from the point of injury through en-route care to life-saving care while reducing the size of the in-theater medical trauma care footprint. And so we're looking at candidates that include, and technologies that include endovascular stabilizing capabilities, blood products that'll be used for resuscitation, hemorrhage control, burn and wound repair and scar mitigation, and a portfolio of medical equipment that'll provide support capabilities during the ground and aero medevac of soldiers. But we're also looking at infectious disease countermeasures. Infectious disease is a significant case and significant cause of hospitalization in U.S. military personnel in theater. Medical countermeasures developed to prevent infectious diseases will enhance unit readiness, soldier performance, and prevention of disease through vaccination will substantially reduce the prevalence of diseases and disease and non-battle injury. Potential technology candidates here include vaccines for drug-resistant malaria, diarrheal diseases, and chemotherapeutic drugs and vector control measures. So we have to optimize our health and performance. So I've talked to you today about the TRADOC imperatives, and I've talked to you a little bit about how concepts become, we use our concepts plotted against our current and operational forces, or future forces, to develop our gaps, and then those gaps lead to requirements, and that's really where industry can come in and help us. So when we're identifying our gaps and shaping our shortfalls and our capabilities, what we need is help enabling focus on the efforts that we're looking from industry. And so what we propose is that as we're developing these, we want to get industry engaged more. Rather than bringing you later during the request for proposal process, we're looking at methods to get you involved earlier in the process. As we develop capabilities, bringing industry in and saying, okay, what are some of your ideas on solving these problems? As we have the 21st order problems of the Army warfighting challenges, what are the industry's ideas on solving these problems? And then taking a look at that and seeing how those fit into our concepts. And in some cases, maybe we adjust our concepts. In other cases, we continue on down that road because we're on the right track. So it's my intention that my team share with you different documents and products that TRADOC produces, but also doing increased collaboration and listening to your ideas. So in that vein, today we brought over some handouts, and we have the Army warfighting challenges on the table. We also have the we have the force design principles, and then on the slide we have our warfighter S&T needs, which is basically the design principle, or the imperatives that I just talked to you about. We also have our O&O site there, so you can look at some of our O&O concepts to look at that. Now those are going to be updated because we're still working on new concepts, functional concepts right now, and we're working on new O&O designs. But these are the current ones, and as those get updated, they will be posted to your site. So with that, I open myself up for questions.
Okay, I'm going to ask the first question, Bill. So,
of course.
You know, we came up and we're in sync. We based our Innovators Corner on the technology imperatives out of the operating concept. And then I started questioning, did we do the right thing? Because we referenced 2025 and beyond. So with these folks in here in the room who have solutions that get us closer to our objectives, does that mean business today, business tomorrow, or business 2025 and beyond?
No, absolutely. So as I talked to you about the warfighting challenges, those problems are challenges that we face today. Those aren't just in 2025 and beyond. And so the businesses that have the capabilities that are mature enough today, as we look at those, we will do what's called, we'll provide that to these, every warfighting challenge has a warfighting challenge lead, and those are at the centers of excellence as well as at headquarters ARCIC. And we provide information we get back from industry to those warfighting challenge leads. Then what they can do is assess that information and then adjust how their interim solution strategies. So we know that we're not going to get to 2025 tomorrow, and there's going to have to be, it's an evolutionary approach to get there. And so as we go through this process, if we come across a capability that's ready today that helps us mitigate some of those challenges, we can put that into the force as an interim solution strategy as we move along and continually improve the force. Does that answer your question, Bill?
Yes, thank you.
Other questions?
When I prepared Bill, I said, Bill, you know, I know you're from TRADOC, you're being filmed, and you've got to stay with the party line. But he said, no, everything's open. So ask him the hard questions, especially how are you going to get your business started? What's the role of TRADOC? He's also a professional contracting officer. So right now he's up on the stage. I take advantage of it, and it is being filmed. So he's got to be honest.
So as Bill said, I am an acquisition officer by trade. I started off life as an infantryman and then switched to logistics and then went into the acquisition corps. And I've spent most of my time there as a contracting officer or as a capability developer at headquarters TRADOC or ARCIC. So I have the how we get new equipment into the system. I understand that. I also understand the contracting processes. Well, the charts are absolutely available, but they didn't, if you notice, they didn't have any words on them. So everything was in my notes, but I can provide the gist of my presentation to Mr. Garland, and then he can post it.
Sir, the entire presentation as you viewed it is being filmed, and it will be posted before you leave today. So you go to our YouTube channel, it's posted. I may ask him for his notes, that the talking points into his charts